Hello, everyone. I'm Stephanie Boozer with CUGC HQ, and I am very happy to welcome you to today's CUGC Connect webinar with HPE. Going to be learning a lot today about bare metal VDI and their newest Moonshot M750. I'm very excited to hear about this, and I know you are too. But before we dig in, just have a couple of announcements for you. As you know, our CUGC local groups are still meeting online, even though we can't meet in person. So I hope you'll check out our events calendar and find your local group and see when their next upcoming event is. We've got the Swiss group is meeting next week, the French speaking. I think they're also going to have some stuff in English too, so don't be too alarmed about that. Also, Connecticut and Rhode Island are coming up, and then our next XL event is the Southwest XL. That's on November 18th, and our XLs are almost a full day of technical content. We've got expert Citrix speakers. Usually we have a fun keynote. I think for the Southwest XL, we have a comedian, so that should be really fun. So definitely check out our calendar. And also this week, we have a user share. Our user shares are unsponsored webinars. Lee Jeffries is a CTP, and he is going to be talking about his community script called PowerScale. It replaced Citrix Smart Scale, which went end of life last year. So if you're interested in that, definitely check that out. Also, if you have missed a webinar, we have our full library available to you on the CUGC website. So all you have to do is log in with your CUGC account, click on the Files menu tab and select Webinar Recordings, and there you go. You'll have all of our webinars at your disposal. It goes all the way back to 2015. That is a lot of webinars, but they're all there for you to watch and download at any time. Okay, so as I mentioned, we have a full library of webinar recordings. So we are recording today's webinar as well, which we will add to that library. You're also going to get a link to today's recording in an email tomorrow. It's going to come directly from GoToWebinar, so be on the lookout for that. Also, be sure to submit your questions at any time during today's presentation. We're going to save the questions for the end, but I do want you to ask them as you have them, just so you don't forget. So put those in the chat window. And finally, at the end of the webinar, I have a short survey for you. I'll put a link in the chat window, and we just love to get your feedback. It's anonymous. No one will follow up with you about your answer, so you can just fill that out and get back to us. We like to hear what you have to say. All right, so who do we have with us today? We have Rich Faulkner. He is a CTP, and he is going to keep an eye on all of those questions that you're going to ask today, because I know you're going to ask some good ones. Rich, would you like to say hello?
Certainly. Hello, everybody, and looking forward to this event.
Thank you, Rich. And also we have from HPE, we have Christian Kojokaru. I think I got it right. He might correct me. He is a solutions architect on Moonshot and Edgeline systems at HPE. And we have Thomas Bulgard. I'm sure many of you are familiar with him. He is part of the Denmark CUGC group, one of the leaders there. He is a CTP and has a host of other amazing awards. I think, Thomas, you might have another slide where you can fully explain all of your awards, but he's very well decorated. And we're very happy to have him on the webinar with us today. So with that, I'm going to hand things directly over to these guys to get us started and tell you a little bit more about themselves. So Christian, I believe I'm going to send the screen to you first. So here it comes.
Hey, Stephanie, thanks. I think we should be able to see my screen right now, correct?
Yes, we see it.
Okay, one of the most common questions, I guess, during these times. So, hello everyone. Thanks, Stephanie, for the introduction. My name is Christian Kojokaru. I'm a worldwide solution architect in HPE. I'm part of the global Moonshot and Edgeline systems, and my main responsibilities are around end user compute. So I'm based out of Romania in Bucharest, working for HPE for almost 10 years now. I think almost eight of them have been working for VDI projects, end user compute, and so on. Started mostly around the 3D graphics a couple of years back, and now fully dedicated to Moonshot, and especially to the dedicated model of delivery that we'll go through in the next slides. And I also have Thomas with me today that will take the second part of the presentation and share some really cool things he tested. So I hope most of you know what Moonshot is, but nevertheless, we're going to run through a short introduction. So we started talking about Moonshot somewhere back in 2012, if I remember correctly. It is a product that came out of HP Labs on a division in our company that was looking at new products, breakthrough solutions, and so on. So the idea of the Moonshot, or how it was first announced, was that it's the world's first software-defined server. And what do I mean by that is that I take an application, I look at it, I look at what the application requirements are, and I will design a hardware platform specifically for that application. So that's where the software-defined server comes from. So what does this give me in exchange? Well, I would say it gives me the best performance per dollar or per energy and so on. So I'm optimizing it for that special application, and then depending on the application, I just go ahead and switch around blades or cartridges, like we used to call them. So if I want to do a big data workload, I have a certain type of cartridge. If I want to run end user compute, like we're talking today, I have a different type of cartridge, and that's what I'm using, and is going to deliver the best performance. So we also wanted Moonshot to be very energy efficient. So back then we looked at common computing architectures, and we said, where can we find, the most efficient platform? And the answer was actually in the mobile phones. So everybody has at least one mobile phone in their pockets, and it actually runs on a platform called on a system on chip architecture. So compared to traditional like CPU architecture, here we have everything running in the single piece of silicon. So we're optimizing everything. We're trying to consume as less energy as possible and deliver the best performance. So we took that architecture, we started to design these hot plug blades, and we built a chassis around them. So you can see right now on the screen the Moonshot chassis, which can basically host 45 of these hot plug blades or cartridges. We also embedded the switching, we embedded the power, the cooling, and we did a centralized management for the platform. So something similar to the traditional blade architecture. Now I see a lot of people, they look at the chassis, it doesn't look like a blade architecture, so they get confused. They don't understand why is the blade so small. It's literally slightly larger than a CD case. So I think the best analogy to the Moonshot platform and the Moonshot chassis that you're seeing on the screen is to think that you have 45 like 1U servers sitting in a rack connected to 2 top of rack switches. Now imagine all of that being condensed into a chassis that's just 4.3U in height. So pretty dense. Then fast forward a couple of years, we started to see the need for edge computing more and more. So we started to have a lot of workloads that were generating massive amounts of data at the edge. And instead of moving all that data to the data center to process it, it was far more efficient to actually process it right where we are creating it, so at the edge. So we took the same blades, they were already built very reliable, and they can withstand, let's say, harsh conditions, and we built some chassis around them. One of them you see on the screen right now, which is called the Edgeline 4000, which is relevant to our use cases, so for bare metal VDI for engineers. So we built a platform that can basically run at 55 degrees Celsius, You can keep it on a plane, on a boat. You can keep it on an oil rig. It sits in supermarkets, in pharmacy stores, and so on. It can host different options at the rear of the platform. So you can have GPUs, which are very important for our use case, and several other accelerators at the back of it. So those were the chassis. These are the cartridges. And speaking of end user compute, so our main topic for today, we have two cartridges that are fully dedicated to this workload. So on the left, you see what we call the M710X. The M750 being the cartridge that was recently announced and launched this year. So we started looking, we want to do end user compute. So what's our goal? I want to deliver a very fast desktop, right? So we started to look what are the features that make a very fast desktop, or what do I need to choose in terms of components or different characteristics when I'm building a desktop for a power user, be it a trader, be it a CAD user, or a developer. So I think the number one metric or feature that most of these users are looking for is the CPU frequency. So that was at the top of our list, and when we built these blades, and the idea was to take a component, so a system on a chip that can deliver the highest CPU frequency available in that form factor. So on top of that, we saw we will need graphics. So we started back in 2012. The M710X is our third generation of end user compute cartridges. M750 is our fourth generation. But we knew that you're going to need more and more graphics. So the embedded GPU or integrated GPU was a must in designing these features. And last but not least, we said we need really fast storage. So compared to other workloads, when I have an end user compute workload or even a dedicated single user working with thousands of very small files comes into play. So I need a really fast storage. So if you look at the specs, for example, on the M710X, we're running a CPU with it has a base frequency of 3 gigahertz and can turbo up to 3.7. It's a 4 physical core CPU. It has an integrated GPU, up to 64 gig of memory, and it runs NVMe storage. The M750 that we recently launched, we doubled on the core count, so that's 8 physical cores. It can achieve an impressive 5 gigahertz turbo frequency. We lowered the base frequency to 2.4, and that's mainly for power consumption reasons, so to be more efficient. We kept the integrated GPU, and it's still using the same NVMe drive, so we can actually have up to 16 terabytes of NVMe storage on one cartridge. So if you take that, for example, and multiply it by 45, you're going to get a very large and fast storage box. Just put a software-defined storage on it and call it a day. So with these cartridges, where do we fit in? So if we look at the end user compute landscape, most of you are familiar with the types of deployments. So, starting from the highest density of users or the lowest cost per user, you do application or desktop publishing. So Citrix virtual apps. That means I take a cartridge, I install a bare metal OS, so there is no hypervisor, Windows Server type, and I run publish desktops off of a cartridge, so I can have multiple users sharing that cartridge. Then you can go through the traditional VDI, which involves a hypervisor, and with the M750 that becomes more and more relevant, and have multiple VMs running on the cartridge. All of you know that. And then on the far right, it's the physical model, so the dedicated model. I am a power user, so I will get an entire blade to myself, which has a Windows client operating system directly installed of the cartridge. And this physical hosted desktop model is the actual focus for today. So when we're looking at the architecture and how to deploy, there is nothing that's very specific to Moonshot. Actually, Moonshot and Edgeline can come and augment your existing VDI infrastructure, and we have plenty of customers doing this. They run traditional VDI for just normal users, and we come in and we address the power users, for example. So it's just a premium VDI offering for them. So it works perfectly fine with your current Citrix architecture, or even better and far more effective, You can just use Citrix Cloud. You can have the Edgeline or the Moonshot chassis on-prem, and you can deliver your desktops to your traders, to your engineers and software developers. And like I said, these are the main use cases that we're looking today with the Moonshot M750. So starting with a trader, if I don't know how many of you met traders or been on a trading floor, but I think they're one of the most difficult type of user to actually please when it comes to desktop performance. So most of them use multiple screens, and now in 2020 they're starting to ask for high resolution just because they need more screen real estate. So they have 4 to 6, some of them even 8 screens per desktop. Most of their content is 2D, so they're running like ticket tapes, or they're running applications like Bloomberg or Icon, and that's full of 2D content. But the catch there is that you need to provide a very good end user experience, because they are very finicky about those ticker tapes. Like, they won't accept any lag to the ticker tape. They want to see it real time. And they typically watch 1 or 2 live streams, like Bloomberg TV, for example, of just watch the news to see how that influences their trades. And last but not least, they're really interested in having a very low latency when it comes to the full system. So, talking from the click of a mouse up to, the time of submission of their trade and so on. Some of the requirements are very common to the engineering users. So again, they use multiple screens, they have high resolutions, they do 3D rendering this time. So there's a lot more 3D content involved compared to the 2D of the trader. They need really fast storage. So they have a lot of large models, and that's one of the reasons most engineering companies move to a centralized deployment model, because they want to move the servers next to the storage that has the CAD files, which are like very large. And something we're seeing with the Edgeline deployments, there are a lot of engineering companies that look for smaller deployments. So I think here the cost of entry point is very important. So if they have like 10 engineers, I'll show you an example further on. It's very difficult to go with like a full-blown deployment. And last but not least, we have the software developers. I mean, not a lot of people talk about them. They typically talk about traders, for example, but most financial companies actually have more software developers than traders, and they need a similar fast desktop. And they're looking for 2 things here. They're looking for the fastest compilation time, which that's directly related to a single thread performance most of the time. So it's very important for them to have a very high CPU frequency. And then they're looking at application compatibility. So imagine most of them now, they're trying to make use of modern technology like container technology, for example. And you cannot afford to give an entire server to a software developer. So you give him a VM. Now, what happens when he runs all his code on a VM? He might get into a situation where he's running hypervisor on hypervisor. So that affects performance and also application compatibility. So if you ask a developer, what's your wish list? If you don't have a limit on, let's say, the budget, he would say, I want to have my dedicated server. That's the answer, or let's say the dream of any software developer in most of the companies. And that dedicated word is really important. So I remember after my second or third POC with the Moonshot and for a trader workstation deal, I understood that it's really, really important to go to the business, so to the trading team, and explain to them that, listen, guys, this is a dedicated model. So they had previous experiences in other companies where they said, we're moving everyone to VDI, we're centralizing everyone. And the traders had a very bad experience with this, mainly because they didn't have the expected level of performance. We even had companies that said our users have quit just because the desktop we gave them with our VDI deployment is slower than the one they have at home. And they said, I cannot work with a desktop that's slower than the one I have at home. I need a really fast desktop. So having this dedicated model and going to them and explaining there is no noisy neighbor, the system is entirely yours. You're not sharing your resources with anyone else. Is really, really important. So they basically figured out, okay, I cannot do VDI, right? Because I cannot give adequate levels of performance. So funny thing, what do some companies do? We call it a trader Jenga, right? So if you look on the right, this is with a company. They basically move their PC workstations in the rack. They just stack them one on top of the other. So just imagine the troubles to manage that environment, or even better, try to service one of the desktops that's sitting at the bottom row or anything like that, or they move them on shelves similar to the picture on the left. Even so, it's a very inefficient use of space and power. And just imagine to do lifecycle management and all of that. And I know most of the presentations nowadays, they talk about COVID-19 implications, but I really want to tell you about something I heard from a customer. And we were talking, about data centers, and the definition of the data center is basically a space where I host my computing equipment and storage and so on. And if you look at the trading floors, or basically, every company's floor right now with everybody working from home, it's just a floor space full of equipment with no people. So it's starting to look like a data center. And we're hearing, different stories from our customers. They're saying, I have all these PCs on the trading floor. I got caught on the wrong foot, sorry. And there was nothing to do. So our users right now, or traders right now, they're basically doing RDP into the PC. And you run into a scenario where the cleaning service comes by, and while they sweep the floor or anything like that, they hit a power button on a workstation, and boom, the trader basically just lost his desktop. So if you come to think of Moonshot, we basically took what's in the picture here. We used enterprise components. So you have a Xeon CPU, you have ECC memory, you have NVMe disk. We added enterprise class management capabilities, so the same management capabilities we have on the rest of our servers or traditional servers. We shrunk that to the size of a CD case, and we hosted it into a platform. So basically moving to that, you can now have something like this, like a home office trader workstation, because your office is on lockdown and everything is coming from a data center powered from a M750 cartridge. This is actually my setup at home, so excuse the cable management, the bad cable management. And this is us testing. So my entire team, the solutions architect, they have a similar setup, so we can understand the issues that our customers are going through, and so we can optimize basically the solutions for them. So here I am basically running 4 screens at 4K resolution. Those are some 5K screens downscaled to 4K on an M750 with an additional GPU card inside the Edgeline 4000. Next year, an engineering customer. And remember how I told you we also have an issue with the cost of entry point into VDI. Now imagine you have 2 to 4 users in your engineering. It's a contractor to a bigger engineering company. And that's what happens usually. If you look at the automotive space, you have smaller companies designing, for example, just the gearbox of a car or a smaller component, and that's outsourced by the bigger companies to different contractors. So they don't have 100 users or 200 users to actually cater for a very big VDI deployment. They have several workstations. They have large CAD files, so they understood the need to have the servers next to the storage, like you see on the left. But again, it's a PC running there. It's going to fail. The management is almost non-existing, and so on. So they moved to an Edgeline 4000. They can even run some storage inside the cartridges on the fast NVMe files. And even so, if you look at the engineers, so I said the traders are very difficult, but most of the engineers are like, I'm not going to give up my workstation. They almost take pride in how performant the workstation is, or how big it is, or how noisy it is, and so on. But from conversations, I think a good turning point is something like, hey, Mr. Engineer, you can actually have your iPad and you can load any model you have. You can sit on your couch, have a coffee, and you can do your work. You don't need to be on the office. You know, here I am at a previous event when we were all able to meet. I was running SolidWorks on a Citrix session on an M710X actually with add-on graphics. And that was a pretty large model if you look at it. And I don't know how smooth this comes through the webinar, but the performance on it was really, really good. So, you know, that couch I'm sitting with the iPad can actually be the edge. So you can have engineering at the edge. You can have an engineer on an oil rig opening his models over there and taking a decision right on the spot. And speaking of edge, here's another use case with one of our customers. If you're fans of the Formula One competitions, you probably saw that on the pit lane, basically the teams have their engineers that look all the time at the telemetry, and they have those big screens. So in the past, they were powered by something like a consumer device similar to a Intel NUC device. So that wasn't built for harsh environments. They actually built like a circuit breaker. So they would just power cycle all of the Intel NUCs at the same time. So they would restart them in case something happened. And this is a workload where if they lose a couple of seconds of the data of that screen, it could mean that they lose the race. So it's very important to have a highly reliable system. So the choice was even to avoid VDI altogether here and move the servers at the edge. So they're now running the Edgeline 4000 with the Moonshot cartridges and additional GPUs right on the pit lanes. They're literally there under the desks. And it's basically delivering very good nonstop performance no matter the conditions, be it hot or vibration or dusty and so on. And last but not least, you know, we forgot about the developers. And this is something we did last year, and I think it proves very well the noisy neighbors situation. So this is a customer that was keeping his developers on workstation laptops, so similar to MacBook Pros or you know, the big workstation laptops. And they were running Windows 10, they were running an IDE compiler, Visual Studio, they were developing code. So here comes the decision, we need to move everyone to a VDI deployment. So their VDI stack for all of the users was built on a hyperconverged platform. It was a latest generation platform. It was using all flash or hybrid deployments on storage. And they moved the developers from a laptop to VMs that had 8 vCPU, 32 gig memory, and all flash storage. But somehow the build time of their code went from under 8 minutes to 14 minutes. So they're an older HP customer, so they asked us, why do you think this is? And we said, you know, it's directly related to the CPU frequency. Even though you have a pretty good stack built here, when you get 16 users on the box or 32 users on the box, sharing the CPU resources, that CPU frequency is going to go back to base slowly, depending on how well you can cool it or power it. So we went in with a POC with the previous generation cartridges, with the M710X and the M710XL, which is a lower power M710X. And we were able to do the same code and compile it in with the M710X in 5 minutes 58. So throughout the day, compare that. And we had a previous webinar with Neil Spellings and Cyril Haag, one of my colleagues. And Neil basically ran some benchmarks and he said, you know, I can save 11 hours per week in developer work. So that's a lot of work you can save just by having a dedicated instance for your developer. So I think it's the best example of why we don't like noisy neighbors, or like one of my colleagues say, sharing is not caring. So before I hand out to Thomas, I just want to have a slide. So this is our bare metal VDI family. This means they are data center platforms that can support a bare metal installation of a Windows client OS. So there is no hypervisor involved here. You're going to see some benchmarks and testing that Thomas has played with. And I would say keep an eye on Twitter, LinkedIn. We're going to soon publish even more information around the platform on the right, because it can basically support bigger CPUs like the Xeon SP lines and way bigger GPUs that we can have in the Edgeline 4000. That means it enables us to do applications like VR or augmented reality or ray tracing and so on. And speaking about videos, I just want to close with a mention that we started to release a series of videos around bare metal VDI. You'll have the links here, but basically if you go to YouTube and you Google for bare metal VDI and maybe HPE, you'll find the first two released videos that we have already available. One is for the traders and the second one is for engineering and BIM workstations. So Stephanie, this was my slide, and I think we'll hand over to Thomas right now.
All right. Thomas, it's coming your way.
Yeah. Let me know when you guys see my screen.
Yep.
And you guys hear me loud and clear?
Yes.
Great. Thanks, Christy. Great presentation. I really like also seeing things Christy showing from the field that we typically don't see out there. So yeah, I've been working with Moonshot for several years, so it's interesting to see new things every day. Anyways, what I'm going to focus on is the work I've done for HPE, which is this EL4000 with the new M750 cartridge. And that's the first solution where it's bare metal offering. But the problem about that cartridge is it doesn't have, they actually do 5 gigahertz CPU. So the cost came on the CPU, onboard CPU they had on it. So the 3D commands it does are not so heavy, which is actually why they have these offerings. So solution 2 is an NVIDIA P1000 GPU, a Quattro GPU, 4 gigabyte NVIDIA GPU. And then the larger one on the solution 3 is the T4 GPU of NVIDIA, where you can use vGPU, you can virtualize it and then have more users on. And if you just want the pure dedicated solution with the T4, that's solution 4, we get the raw performance in bare metal. So that's how we did the tiering of these four solutions. Now to do some profiling with this, where you say, oh, what kind of applications are we talking about? So in a BIM world, it's quite important that when you're working in AutoCAD, you can actually, typical it's 2D. If you do 3D, more high-end 3D plugins with AutoCAD, I would recommend going to solution 2. So solution 1 is very, very light, where you do, but many engineers actually also do processing in CPU, and this is where the M750 is excellent. It's the first CPU in the edge or data center where you do 5 gigahertz, which is very, very awesome that you get that. Now, so the solution 2 in BIM world, you typically have AutoCAD applications. People also work with Revit, and then they on another screen they work with Navisworks. So typically they look up very high level on when they model a building, and then they look at more advanced graphics. That's what the Navisworks is, where they move around the objects. Or also some customers they use in Inventor with that. So solution 2 is a great use case for bare metal, where it's an engineer, he gets his machine, he gets dedicated 5 gigahertz CPU, and you get a dedicated NVIDIA P1000 GPU, which is Quattro capabilities there. Now, if you want to virtualize it, you can do that with solution 3 and then have more users on from 4 and up. But of course, there is a cost associated with that, with performance, and I'm going to dig into that with all the tests I've been doing with it. And then we have the solution 4, where you have, again, this is typical where you need more horsepower. So you get a 16 gigabyte GPU memory frame buffer. And that's typically used when you work with applications like 3ds Max or Arnold, or you do rendering, or you do light, medium, VR. Then you can do like VRED with that. This GPU is actually really phenomenal. The T4 is very powerful. And again, I'm going to show you that later. I have some pretty exciting stuff, so you can see what the T4 really is capable of doing, which I think is quite amazing. So what I have typical as a customer, a Citrix customer, you can use Citrix Cloud with this solution. You can also use on-prem. In my data center, I have a very isolated lab. There's no actually connectivity. You can connect into it. So my stuff is very on-prem, secure environment. Citrix Cloud is, of course, also secure, but it's just here for this use case, I didn't use that. But you can use, if the customer, use one or the other for all these 4 solutions. That's what I'm trying to say here. So what I have in my labs is these 2 4K monitors, which is hooked up through the display port on the latest generation T4 740 thin client from HP, which is the most powerful thin client on the market. It runs ThinOS on that. So the cool thing is here, what I typically see of all 4 solutions is with Citrix XDX is that the bandwidth, it really depends. You're only consuming when you're using. So again, it can be from 20 kilobits on these 2 times 4K monitors, yes, on the thin client when you then connect to your applications. I did see that. And of course, you know, if you have video streams and you have you know, objects moving around, of course then you push the frames. That means you're consuming more bandwidth with that. Now you can also use without just these extension GPUs, but the onboard GPU. What I want to highlight here is that they don't use the NVENC for this, so it's not capable of doing that because of course it's an Intel GPU, it has that. So no intensive 3D application to do that. But the awesome thing is you can run your very high-end, you know, 4K spreadsheet, and you can do even high-end videos and other applications. Now, if you dig into some of the information I have here with the long-term search release CU1, we can see with this workload I have here, I actually don't use that much of the computer I have, which is great. So I'm getting this amazing experience because it's a bare metal system. That's, you know, you're getting, there's no noise enablers, it's your system, and you know, that's the power of a bare metal system. So if you need more experience, more resources, well, you know, you have the system to push it. So that's the benefit of it as well. So what I've done here to take it further, I did the testing between the NVIDIA P1000 together with the M750. So that's to the left. We have the cartridge. The cartridges are actually quite small, and you know, the GPU is also small, but it's I don't know. It's, for me, it's just astonishing every time, you know, I get the hardware in the hands, and it's really different compared to other physical servers you're used to. Like, you get so much compute in so little form factor. The size of the P1000 is actually the same as the NVIDIA T4 on the right. Now the difference is, again, so on the left it's a 4 GB GPU frame buffer, and on the right is a 60 GB GPU frame buffer. You also, when you use the T4, you do need a vGPU quad license when you use that. So where you don't need a license with the P1000. So of course there is some difference between these 2 GPUs. What I have in my system labs is both of them have Windows 10 1909. And I use these quattro drivers that matches for, you know, GPU at that time. Of course, these are already getting released new. And I used the long-term service release here in the platform with Citrix. The reason I did that was because it is the last long-term service release. It will be supported for a very long time. So I think that's really, really good, because also it's, yeah, I think it for some, you know, they would like to use that. Of course, there's also benefits of using current release, because then you can, you know, you get all the latest protocoling enhancements and so on. But I use this one here because this, I think, would be the best choice in general for customers, and also if customers want to retest to see if they get the same results as I did. So let's dig into some of the results I'm talking about. What am I talking about? So this is Autodesk Inventor 2020, where I'm using also an application that actually could do benchmark. So the benchmark application runs simultaneously. I run them over many times, not just one time. And then I get, you know, the average between all the tests, and then I put that in. And that's what I get here. So these results is running a 4K resolution on the thin client. And what we can see here is the T4 is delivering a 25% faster performance by having less seconds. Now, for a customer, less seconds means earning more money. And you know, when people say it has to be cost effective, many times people look at hardware, but you should also look at your business, because if you're reducing your time, that means reducing time to do more. And that's, I think, is something we should really focus on. Reduce time to do things more, especially here, and you know, COVID, or if we didn't have COVID, I think this information is really, really critical when we are designing computer systems. Now, if you take Adobe Photoshop, this is the CC, the latest release. I'm using here the Pocket system, which is a very famous American company that has developed this. Everything of this is free. There's no, you know, bought software I'm using. I also made a blog post about actually will get released after here, this CUGC, but where you can go in and download all these software, and then you can actually redo the test if you want to in the environment. So the GPU overall scores I get is again here 25% faster with the T4, which means I'm getting, you know, I'm capable of doing more. So this is where it also comes down to the profiling. Do you need all this compute? You know, do you need all this GPU? Well, it depends of what you're doing as a user that justify your investment on, you know, either doing the P1000 or the T4, because both do a great experience. But this is the application. How good is the application performing? And Firemark is a very intense GPU application that many companies uses for the testing. I always use this for 7 years. It's on geeks3d.com. You can download the Firemark, and it pushes the system to the max. So it's really, really great to do that. What you can see here is that with the P1000, it delivers 25 frames per second. And with the T4, it delivers 66 frames per second. And at a high score is also 3 times faster, almost a little bit, you know, almost 3 times faster. And this is in 1K. So that's interesting. Now, spec workstation, spec.org. This is an open standard industry. Many vendors put together, so they can benchmark different high-end CAD applications. It requires a lot of space to run this, and it requires a lot of compute. I've used these before in some other analysis I've done, and here I'm taking the Autodesk 3ds Max application, which is a very high-end 3D application from Autodesk, and we can see the T4 is delivering 3 times more computation. So that's why you're paying more money for the T4, but you also are capable of doing, you know, 3 times more. Yeah. Oops. Let's see here. Next one I want to focus on is the CATIA. So CATIA is a very common used application in airlines and automotive and other companies. So it's a very high intense application. PTC of Creo is also a very known application used in all kind of industries, turbines, all, you know. It's a very high intense application. So I ran these 2 workloads, and without digging into the raw score, I just want to highlight again that the P1000 is we are seeing, so, you know, I'm getting more performance. The total performance is way better compared to the P1000. And this, I think, here when you're working with these kind of applications, I would not hesitate to invest in the T4, because you again, this is the time when you work with a model and you wait, right? It does a rendering. You create the design, the model. You don't want a slow system with that, but of course if you want cost is a problem, you know, P1000 is it. But if you want to be more productive, that's the T4 are making you capable of doing that with this high-end application. So this is why this score is so important that I'm sharing with you. The Siemens NX is an application from Siemens, and it's used for when companies do all kind of things when they're designing factories and yeah, all kind of things. SolidWorks is also used for designing where people design a product. So if they design, the next toilet or radio or whatever, I've seen customers using this application for that. It is for different things. Each application is different for different verticals, and this is why I put these applications into this benchmark I have right here. And Autodesk Showcase is also another one high end. Now I run all these 3 different applications in the workload, and also I got a score between 2 to 3. Now, if you are again very interested in saying I'm only interested in the SolidWorks, what Thomas got out of that, then you can get that score information right here, and that will help you. That I have this data for you right now. So I think it's really, really good data. Basemark GPU is also an open standard. It's free application. You can download this graphics application, and we can see the frames again we get inside the application. It's not Citrix, but it's the application, the frames. That's why. Let me make that very clear. So what I get here in 4K is I get on with VDI P1000, I only get 19 frames and I get 58. So I'm delivering my application, I'm working 3 times faster. Well, the benchmark is working 3 times faster, so it's performing much better, which is of course why the score is so much better here. And super precision is very common used for many different people in the industry when they're testing things. Billy Trich, I know he's been using it. Other guys, Ruben, and many people, the CTPs have also used it, and industry experts out there. I like using this test. They also even have a VR test, but this is the normal bench super precision where I'm running in 1K, and I also get here 3 times faster with T4 GPU. Both with frames and even with score, so that's that's pretty important. In the 4K, I get also 3 times faster performance with that. So that was a lot of testing I went through, and I know I highly recommend when the blog I can release it, you can go in and then read the more information how I actually did the things, and if you want to redo the same thing, you're more than happy to do that. I am sharing the entire methodology, how I do this. There's no hidden information. It's a very honest benchmark I've done. So what I'm doing here, the next thing is I'm actually testing the solution 2 and solution 3. So what is the solution 2? That's the NVIDIA P1000. And solution 3 is not the bare metal, what we saw before with the T4. This is where I actually have 4 virtual machines running on the Citrix hypervisor 8.2, and then I'm using the vGPU manager, and then I'm virtualizing each machine has a virtual GPU, a T4Q, which is Quattro functionality, and then they get a license, each one of them. Now I'm running these things simultaneously, and let's just look at this test setup. What does it look like? So yeah, this is the hardware, and the stacks, the software stacks, as you can see, the left is bare metal. It's Windows 10, it's a Quattro driver, and it's Citrix and 7.19.12 long-term series release. On the right, we have the M750 and then the NVIDIA T4 GPU, and then I have the Windows 10 1909 and Citrix hypervisor. Then I virtualized the 750 with Citrix hypervisor, and then I use the vGPU manager in that, so you can virtualize the GPU, and then I give each machine, the GPU for Q, and then I install the driver, and then I have Citrix on top of that, and then I'm of course I have my applications. So the Firemark, what I want to show here is these are 4 simultaneous users running on the right, and I get a maximum frames of 56. But the high score is less than the P1000, and of course this is the noisy neighbor, principle. But the application is still, you're actually making the application work faster than the P1000 with the frames. So this is again, where it depends on when you need. If you want to virtualize, but there's also a cost, and you can see that by the score. But again, then you get more frames inside the application. But if you have the 4 users working very intensive at the same time, then the noise enabler actually happens. That's the score. You have to look at that, where you then get less. So we put together this kind of, what do I get as a performance per dollar price performance, where we are measuring with the P1000 and the vGPU T4 4Q with the hypervisor, and then also the bare metal system. So we have, the information is right here, and of course, what I want to share that is, this is what you pay for what you get. So if you want to get, virtualization has a cost, right? It does, because also you need to maintain, the software and so on. But of course, it's great if you want to, have maximum efficiency of the system. But there is a cost behind that, and the cost is system performance. What we see right here in these benchmarks I've done right here. That's what I'm trying to say. That. So yeah, bare metal virtualized. To be honest, the systems are made fully functioning, and supported. You can virtualize with any hypervisor, and with the Citrix hypervisor, been working for many years. With these cartridges, and also it's working with the latest cartridge, the 750, and it works also with the onboard GPUs. If you want to do that with even P1000, you could virtualize if you want to, but there's a cost behind that. So you can also take many Edgeline 4000 systems in a rack, and then you can. Now the great thing about doing that is then you have all the connectivity internally. With the switch, so that gives some many benefits, and actually this can be used for many things. I've seen some customers where they use this as a service provider, so they have different customers per chassis, so they're very efficient. And I also seen some customers where they virtualize even further, because it can be, everything is about cost. But again, high end, we need bare metal systems, and this is also what this is for. Where we get the engineers and they say, here, this is your system, it's not virtualized, you get exactly your own machine, there you go. Again, something I just want to very highlight here, because compared to the previous generation of cartridges, they had very powerful, actually onboard integrated GPUs, and they don't have that right now. So the 750 is awesome for 2D graphics, but if you want to use stuff like Revit, like I'm showing right here, here I have actually, this is a normal sample in the 4K, so it's a 4K on the thin client. And what I want to highlight here is the 3DE, which is the one that has the impact. It's up 98%, and that's not good. And that makes an impact, which makes it not good for the user, right? So the user will complain and say, oh, it's laggy, I can't use that. Which is why then you need to look at the P1000 or the T4. Here, this is a great example on where I'm using the 2 monitors, and I'm also using the integrated GPU, but I'm running a full screen 4K and really pushing it to the max. But it delivers. It actually does its thing. And I'm also running here 4K Excel spreadsheet with tons of information put in it. So that's a typical scenario of the people who want 4K, 2x 4K. And the other setup I have right here is the trader workstation application, which is Reuters, a very high intense application, very typical used. But here you can see on thin client with 2x 4K monitors, and I'm actually capable of delivering a great experience. You can also do this with the onboard GPU, but if you're using, again, it all depends on what you want to do. But of course, if you want to get the fastest and the best, the T4, gives you all the percentages of doing that right here. Let's move on. So we're almost wrapping up, and I hope I haven't made somebody I'm bored you to death. So I want to also say, hey, how can I make this pretty excited? Like maybe you already seen so much what he's done before. So I was like, you know what? I want to take this amazing hardware, and I just want to push it further. I want to push it further and try this new EA. Electronic Arts has made this new Star Wars Squadron, which is also been able actually works in VR, but it's a very, very, very high intense game. It's really, really intense. I have some machines where I can't run it on. So I put it on Citrix here, and yeah, I want to show it. So let's see here. So I'm doing now a live demo. So let's see here. You know, I'm like, normal, I would record things. I was like, no, I'm not going to record it. I'm going to show my system. So I'm connecting in here to my T4, the M750 with the T4 GPU. And I'm crossing my fingers. I hope everything goes well. Let's do that. So you can see the small like for you guys. So I have here, I'm starting up the Star Wars Squadrons. I'm so excited I cannot pronounce it. Okay, so again, this is 5 gigahertz and you know, CPU I have, and it has the T4 through the PCI lane, and it is really, really cool. Now, I can see there's a small lag, but I know you guys are going to see what I'm seeing here. So bear with me. Okay, I'm going to just do like this. Now, since this is GoToMeeting, I know that the lag is potentially pretty bad. So not to spoil things, I am going to record this and put it on YouTube as well. So,
Hey,
but I
Thomas,
really
I
want to
don't know
show.
I don't know how it comes for the other attendees on the webinar, but for me, I just see a frame like every 6-7 seconds. So I think it might be a better idea that we actually send the link with the recording for this, because it's quite impressive, and also for the clip you did where you move the windows around and basically see how fast and snappy the desktop is. So that's definitely a better approach, because it's not coming in smoothly. And maybe we can save a couple of minutes for questions now.
That's true. So I know I took a small risk by doing it, and also video through GoToMeeting is not the best to do. But I was like, actually, this is not a video; it's actually live. I'm showing, you know, the Citrix recording on it. But the load times for me, Christian, what I want to share is I'm so excited because I'm running for Citrix, and it is actually insane the experience I'm getting. I'm getting no frame drops, and you know, I'm not kidding. Citrix is delivering the best. You know what I'm seeing, and I'm a gamer, so you don't want, you know, frame drops when you game. And I think that's the amazing part is that the Edgeline is capable of doing that. I'm not saying that it's a game system, but actually it is a game system, and it's competing against a very high intense, you know, application that I have in home that I do for VR and stuff like that. So yeah, I know you probably can't see it, but I think, let me just see here quickly. Whoa, wow, you guys are seeing very no frame drops, like 2 frames a second, right?
Exactly.
Really, really bad. Okay. So what I want to share here, what you don't see, so this is real-time rendering, where you see the TIE fighter, and I'm moving around the things, and it looks now for you guys, and I can see it's quite bad for you what you see, but I'm seeing, you know, I'm getting the 60 frames and no drop, and it looks like a movie scene, and that's how the game is. So, you know, all the way when you go in, and then you get the TIE fighter, you hook in the joystick, because the joystick also gets recognized in Citrix, and then you fly the TIE fighter through this small cartridge with the T4. It is, I've never seen and thought you would be able to do that in a system like this. Keep in mind, I would be able to have 4 of these high-end game machines, using only 800 watts. I have never seen anything like this before, never. So for me, this is next, right? So what I want to do next, of course, let's wrap it up. But that's like doing VR on this and show you guys how great is VR, running with this. Because I can run any kind of high-end game on this. It is really amazing. So yeah, that's I'm going to shut this one down here.
Thanks, Thomas.
Yeah, thanks, Thomas. We'll go ahead and jump into the questions now while you're shutting that down, if you don't mind, because I think these questions are directed to both of you, and you can pick out who wants to answer them. The first question was from Limbo, had to do with can you have a hot standby blade?
Yes, you can definitely have that. You just need to, let's say, architect it at software level. What most of our customers do, they keep the same image on all of the blades. If something happens to the user, then he basically just restarts, and then depending on the profiling tools you're using, everything gets applied and he logs into a different blade.
Okay, he also asked if you can create a Windows cluster in the blade chassis. Did you hear the question?
I think that's a question for Christy, right?
Yeah, and
Oh.
it looks like we might have lost him.
Okay, well, I'm going to say that the Windows cluster can be created, but usually, I mean, it's going to depend on which kind of cluster you want to do, because you're not going to have shared storage that you're talking to. So if you're doing something where you can either host the storage using Windows file sharing capabilities, or a scale out file server cluster you could do, but without the shared storage, there would be some limitations to what you can do on the clustering there. Stephen Wright.
So I just want to share a little bit there. So
Okay, go ahead.
I see some different customers also using this for storage space direct, and I know it's very popular right now in energy who uses vSAN with this. Okay. So yeah, I hope that helps the question. So it's a very agnostic system. That's what I want to tell.
And it's nice because you are installing it on hardware directly, so there's a lot of choices that you can work with. Stephen Wright asked, is my understanding that AI uses GPU, so what is the power level of Moonshot and can it grow? I think we saw the different choices you can put in on the Edgeline side, where you can put in the different graphics cards. So are there other options also besides the T4 and the P1000?
Yeah, so there's the AMD, the WX 4100 is something I did a test with, I think like 2 years ago, right, Christy? We did that. I did for HPE. So, but the problem has been more like drivers and so on. I'm not saying AMD is bad, but market recognition is NVIDIA, right? And for me,
we're also seeing the request for like data scientist workstations. And with the Edgeline 8000, you basically don't have any limitation in terms of GPU power. So you can go all the way up to the highest, biggest GPU you can take off the market.
Yeah. So you can take the RTX 8000 and eventually the A when it comes out, and then potentially put that in.
Okay.
Which is the Ampere GPU from NVIDIA. But right now it's the RTX GPUs which is supported in the EL 8000.
All right, Stefan also asked, what are the management tools being used?
So starting from the hardware level, each cartridge or blade gets an ILO 5. Then the big chassis, the Moonshot M750, has a chassis manager embedded within the chassis, and then going higher up to software, we have a tool set, for example, like ILO Amplifier, which allows you to do large-scale management of the Moonshot platform.
Okay, and then for loading the operating system and so forth, what are you using there?
So this is where we stick to industry standard tools. So we support Pixie booting, we support Windows deployment services, SCCM, you name it. There is no
Yeah, so
no.
what I want to share, what I do with customers here, when it's Citrix, I do use PVS, and very, very successful use PVS for Moonshot, and also for Edgeline. Because then you do bare metal, right? And you then take care of the image management. You stream down the OS.
Right. Yeah, I remember that when PVS was first purchased, it was actually set to do building of desktops and booting desktops from an image, physical desktops.
Correct.
So I remember. Okay, and then failure support is one. If one of your blades crashes, how long does it take to recover?
So this is all on the software level. There is basically no, I mean, it's not a platform where you can have multiple blades in a high availability. From a hardware point of view, you just need to reconnect. Like mentioned previously, we typically have customers just reconnect to their Citrix stack, and that, depending on the profiling tools, takes anywhere from a couple of seconds up to a minute.
Okay. And then what version of Zen Desktop and VDA are you using? I think we showed that in the slides, but
Yeah, I can say that again. So what I did, all the tests I did was long-term service release 7.19.12 CU1. But what I did with the Star Wars, and I know you guys didn't get the full experience, I will share it on YouTube, but that's the latest release, the 2006, the CR.
Okay. Matthias, do we get charged the NVIDIA software licensing for the P1000?
No, I
No.
can reply that because, yeah, there's no license for the P1000.
Magnus asked, does the M750 have the ability to plug in a GPU card? As I thought it had Intel Iris built into it. I think we've seen that also, that we do have the multiple GPU choices, or you can just use the built-in GPU on the processor. You guys want to comment on that?
So in the Edgeline 4000 chassis, you have space for additional GPUs. If it's being used in the M1500 chassis, then your only option is to use the integrated GPU. Mainly that's a density play, so you get like 45 machines in 4.3U of rack space.
Okay. Reynard asked, is the M750 plus P1000 combination supported for multi-user?
Yes. So when you say multi-user, it's supported with Windows Server because Windows 10 multi-user is only in Azure. I hope that makes that very clear. Multi-session is Windows Server on-prem. That is fully supported. So you can do, because it's Microsoft 2012, 16, and 2019. And of course, you could also do 2008 R2, but then it's not supported setup.
Okay. Mikhail asked, what about Microsoft licensing on bare metal VDI? For virtual environments, we need a MS VDA cal or RDS cals. So can you speak to those on the bare metal?
It's a similar situation with the bare metal. What we've seen on the market is that most customers have that subscription, which is the software assurance, and that basically enables you to remotely access a Windows client OS. So it covers the VDA part. Not sure if Microsoft have recently changed their licensing scheme.
Yeah, my experience is that the MS VDI or VDA is required if the endpoint is not running Windows, and that's why you run into the extra charge there. RDS cals are always going to be required if you're doing a server-hosted desktop.
Correct.
Okay, and Tobias, good to see you, sir. Is asking how much additional cost does a T4, A100, etc. required NVIDIA licensing add compared to the P1000 or other non-grid GPUs?
So I can explain that a little bit, Christian. Yes, of course you're going to say that, but you first of all you do need the license, right? So if you do RDSH, it's a VApps for NVIDIA, and if you do VDI, then it's the Quattro license or the new VWS license. And you do need that license in bare metal for the T4, or if you virtualize it. That's the EULA NVIDIA has. Now, the pricing wise, yeah, of course, it's more expensive, but I want to hand that over to Christy.
Well,
And then
there's nothing. Sorry?
I was going to say, and you also have to add in that if you're doing the high-end GPU, it's a different license than if you're just doing a standard vGPU as well.
Correct.
Yeah.
You need a remote workstation license. So.
Oh, you're
Okay.
talking about Citrix, right?
No, I'm talking about for the NVIDIA grid licensing comes in flavors.
That's what I said.
Yep.
Like the VPC, right? And then there's the Quattro, but we are talking about the P1000 is a Quattro GPU. And of
Okay.
course, if you do the T4, you would also then use the Quattro GPU, right?
Right.
From a cost perspective, I would, yeah.
I think
Okay.
the cost is an offline conversation.
Yeah. Taran asked, have you tested the multiple screen setup with HP RGS instead of Citrix?
Yes, we did. And with a 4-screen setup, it runs perfectly fine.
Magnus asked how many displays were used during the testing, and if multiple, and did those test results show different data?
No.
So you're saying that it didn't matter how many? No, you didn't test it with multiple screens. Is that what you're saying?
No. So all the tests I did was using the HPT 740 thin client, FinOS. I'm actually not using IGEL. I could have even boosted it more with the IGEL OS, but I didn't. And then it has the two 4K monitors attached to that through display port. So it gets the fastest throughput with the hardware. And then I have the long-term service release workspace add on that. So I did that testing on all the things that I shared with you. That's the same setup. I hope that. So yeah, and I ran them again and again and again, right? So that's the information you got there. I hope that answered the question.
I would like to add here. So besides the benchmarks, which typically go like full blown on the GPU and the CPU, what myself and my colleagues are typically doing, we're just using the machines for day-to-day work. And there are two scenarios. So M750 inside the big chassis, the M1500 with the integrated Intel GPU, we can do dual 4K screens on a Windows 10 deployment, or you can run up to 6 full HD screens if your thin client or endpoint basically allows for that. If we're moving towards the Edgeline 4000 and we add the NVIDIA P1000 there, we get really good performance with quad 4K screens. So I think that gives a significant screen real estate for any user out there. And we've seen traders starting to ask for like dual 38 inches, for example, which is like a dual 2K resolution. So both setups, they can cater to that.
Okay, and Hayden asked if Citrix was the only remote protocol available on Moonshot.
No.
It's the best.
Thorsten commented about they said that he just finished building traders on M710X in Switzerland. They were pushing the cards pretty hard, but it had up to 6 screens on Dell thin clients and thin OS.
Okay, good feedback.
Taran asked, does the onboard GPU allow 3 to 4K resolution? I think we've covered that one.
Yes, up to 2 screens.
Magnus asked, what ICA connection policies are you using? Is that something you've got shared out somewhere, Thomas?
I'll share that when I shoot it and release it. So I can see it's the H264 and YUV2420 with hardware encoding enabled and image quality higher.
Okay. And John asked how many slots are available to install the GPU card.
In the 4000, we have 4 slots, so 4 cartridges and 4 GPUs.
Okay. Anchor asked, when using the EL4000, the 750 with a P1000, if you're using the VDA on top of Windows 10, can you get more GPU acceleration to more than 4 monitors? For example, a trader having 6 or 8 screens.
With the P1000, I think if you're not using 4K resolution, we can definitely do that. We haven't tried, to be honest, because we moved to the P1000 especially for running more than dual 4Ks. So we had some requirements for 4Ks, and the onboard graphics cannot go that far. So we thought, I think with the Intel being able to drive up to 6 screens in a full HD, I don't think that would be an issue for the P1000, but it's not a tested configuration yet.
Okay. And Taran asked if this solution can be secured on an existing Moonshot chassis by taking out some of the existing 710s. So I'm going to say that's probably just going to be in the chassis. Again, you're still going to be limited to the local GPU. And
Correct.
if you got 710s, then you've got GPU, right?
Yeah.
Karin asked about RDSH-based GPU users on Citrix VDA bare metal.
That's a pretty big use case we have. I would actually say that the biggest deployment of this sorts in the world, any hardware, any software, is actually running Citrix on Moonshot and pushing anywhere close to 200,000 users, especially during the COVID times. And we do use and leverage the GPU on board for GPU acceleration and HDX encoding. So it's a quite optimized and used deployment model.
Okay. Linville asked if data center licensing would cover all the servers in the chassis.
I'm afraid I don't know what data center licensing is.
I think, well, so Windows data center licensing is going to be the number of cores, and it's associated with hypervisor solutions. So if you're running bare metal, I don't think you're going to use data center licensing. You would need on the blades, if you're going to use Windows Server, you would need a server license on each of the blades.
Correct.
So
Thanks.
make me very clear, the T4 still need NVIDIA license. So it wouldn't cover that.
Okay. And Sergey asked about the modules with AMD graphics. I think we've converted on that. And John asked if it was Thin Pro on the T740.
Yes. And
Okay.
so I just want to make a statement. I could have pushed it even further by putting in IGLOS because they've done a more improvement on actually the client. So that's something I do want to do on it. But I'm using the stuff built out of the box when you buy it from HP, the T740 client.
Okay. And Anchor, sorry, I'm sure I'm saying that wrong. Anchor Patel is asking that he thought that Citrix limited the number of monitors that can be GPU accelerated.
No, you can actually have up to 8.
Right.
Yeah, and without ESH, you can have 64.
Right.
Wow.
64 monitors, man. That sounds like a plan. Okay, I think that's all the questions. You can also reply in the question panel if you want to be contacted on a follow-up. I think there was one that we are going to be trying to follow up with after the session. And Stephanie, I think it's back to you.
Thank you. Yes, definitely. I know that some of you may or may not have opted in. So if you ask some questions and you didn't get all the answers, just pop in the chat, that it's okay to be contacted. Excuse me, and I'll make sure that your question gets over to HPE afterwards, and we'll get you some answers. Also, I put in the chat a link to the survey that I mentioned earlier, so if it's super fast, love to get your feedback. And if you opted in for a chance to win the Sonos One speaker, I will randomly draw a name after the webinar. I wait until the webinar's done because people register and sign up, you know, after we're in progress. So I want to give everyone a fair shot. So once I pull the report, I will use the Google number randomizer and draw a winner, and I will make that announcement on Twitter. So make sure you follow us at MyCUGC on Twitter. It's also just good to follow us so you know what's going on, what's coming up. All right, thank you so much, Christian and Thomas. Appreciate you spending time with us today. And thank you, Rich, for keeping an eye on those questions. There were a lot of questions today.
Yeah, it was good. It was very interactive.
Thanks,
Yeah, you did an
Stephanie.
awesome
Thanks,
job.
Rich.
Thanks, everybody.
All right, thanks, you guys. Look out for the recording tomorrow, and I hope to see you on another CUGC webinar again soon. Bye, everyone.